Hello friends, we are back with a new video, and this time we have got a sample of rice washings. Now in our day-to-day life we eat rice, and this rice needs to be boiled to get our thing, and this rice is actually uh, sometimes it's adulterated. Now how it is adulterated? It is adulterated by two things. First, to keep looking it very white, super white, starch is added in the bags, the 20 kgs or 25 kg bags. They are packed. When they are harvested, they are packed in 25 to 20 to 25 kg packs, and these rice are adulterated. And to look them super white, sometimes the variety of the rice does not look white. So to make it super white, lustrous, they mix starch with them to make them super white. And second thing is they use a pesticide. It's a very cheap pesticide, that is ammonium phosphate, the industrial grade ammonium phosphate. And this ammonium phosphate is very dangerous for our kidneys. So here we are going to perform two tests regarding the test of starch and regarding the test of ammonium phosphate. So also in the second stage, the second part of this video, we are going to look for the microbiological culture, because if the starch contents is found in the rice sample, the rice washings, then there should be the presence of fungus or parasites or anything else. So that we will look around after this second part of this video. Now in the first part of the video, we are going to chemically test the rice washings. So two chemical tests are necessary. One is the test for starch, and the second one is test for phosphate, ammonium phosphate or phosphate, whatever it is said, a phosphate, that phosphate pesticide. So first of all, we will be taking one rice washings. As you can see, this is the rice washing in the camera. You can see this rice washing is totally milky white. The rice washing should not be milky white, first of all. In the first vision or visual test, you cannot see rice washing is so milky white. It is full of white. It is milky white. It is like looking like a milk. I am just in the test tube, in this centrifuge tube. It is looking like it is milk, but it is not. Should not be like looking like that. It should be transparent or just little bit hazy, not like this. So this means there is some alteration, and that alteration is definitely starch. So what we will be doing, we will take a very clean test tube here. In front of me there are test tubes, and we are in this test tube we are going to take some of these rice washings. So little bit rice washings we will be taking, and you see it is like looking like milk again. So this we are going to mix some iodine. So here is our iodine. This is iodine solution. So this iodine you will get in the medical stores in the form of betadine, that disinfectant betadine. You'll get in bottles, big bottles, and they were betadine. It's a little bit costly, but it will get that one. So you can keep it in your house to get this. So now we are going to mix some iodine solution here. As you can see in the camera, I'm mixing some iodine solutions, and let's see what happens. So its color has changed from brown to blue. So this has become blue. You can see it has become blue violet color. So it has become blue violet color. So definitely it consists of starch. So this proves that it consists of starch. So this is one test. It has gone bad, that it has contained starch. So now we are going to make the second test. So we are going to keep this aside. The first test is proven that it consists of starch. Now for the second test, we will take another test tube, and let it not clean. So let us find out the clean test tube, and this is another test tube. We will be going to take another amount of starch, and no, this not this one. Let us take this one. So another little amount of this rice washings. Here it is some little bit of rice washings. Now this we are going to test for phosphate. Now this phosphate test needs little bit different kind of reagents which you will get in the chemist shops. These are not normally available. We need three reagents. First of all, the nitric acid, dilute nitric acid. Second thing is ammonium molybdate, and the third thing is tartaric acid. These three reagents you will definitely get in the chemist shop. I will put the name of these reagents in my description box, so don't worry. So this you will get in the chemist shop. These things you get. First one is dilute nitric acid, and second one is ammonium molybdate, and the third one is tartaric acid. Dilute nitric acid is just nothing but concentrated nitric acid mixed with water, so that becomes dilute nitric acid. Ammonium molybdate, just one, so 500 milligrams of ammonium nitrate you mix with ammonium molybdate, you mix then ammonium molybdate with about 10 to 15 ml of water, that will give you ammonium molybdate solution. And the tartaric acid is also same. Take about one little bit of 500 milligram or 1 gram of tartaric acid and just mix it with 15 to 10 to 15 ml of water, that will give you a tartaric acid solution. Now, so what we are going to do? First, we will mix this nitric acid in this sample of the rice washings. We will go to mix with some nitric acid. Now this nitric acid is mixed. Now we are going to use some tartaric acid solution. We are going to add some tartaric acid solutions. First nitric acid, then we are going to mix some tartaric acid solution. This tartaric acid solution is mixed. Then we are going to use ammonium molybdate. Then we are going to use some ammonium molybdate, and this is molybdate. And already you see it has started becoming, change the color. And now we are going to mix it well, and we are going to heat this in Bunsen burner. So what we are going to do, we are going to heat this in Bunsen burner. Already it has become yellow. You can see when I am heating this, I will just heat this. If I move the camera, you will be able to see that I am heating in the Bunsen burner. So you can see the Bunsen burner there. Here is our Bunsen burner. So I am just heating the tube, and you can see the tube is becoming yellowish, slight yellowish. The tube is becoming slight yellowish. Now you can see the color has changed from white to yellowish. This was our color. This was our initial color, and this has become white, creamish and yellowish color. So this proves the presence of phosphate. So if we heat more, so it will become yellowish. And if we keep it for standing for a few minutes, you will see, after that, you will see it has become yellowish, which I will show you after 2 or 3 minutes. Just I will be waiting for 2 or 3 minutes, and I will show you the test tube again, and you can see it has become yellowish. It has become beautifully yellowish color. You can see even the yellow precipitate over here. So this proves a high amount of phosphate present in this solution, in this rice washings. So this is the presence of phosphate. Phosphate actually phosphate is a very dangerous chemical, and which makes our renal system a big push to our renal system towards danger. It gives a big push to our renal system towards a great danger. The kidneys sometimes fails in the presence of phosphate. The renal stones are found in the phosphates due to phosphates, formation of phosphates. So I will be requesting you people to be careful about these rice washings. Please carefully wash the rices to remove all these ammonium phosphates and starches from rice. Because starch, what it will do, starch will make our digestive system slow and sluggish. It will make, inevitably, carbohydrate is very hard to digest, and even over that, if starch is present, then it will be more hard to digest. So more and more it will cause our gastric disorder for this starch and the presence of starch, and the presence of phosphate will push our renal system to a big failure, towards the big failure system, towards the big failure, the state of failure, so renal failure. This continuous addition of phosphates and all that will cause you renal failure. So as you can see, after few times, you can see a yellow precipitate is over there. You can see a very clearly if you see in the camera. I'm just putting this camera just very close, and you can see a yellow precipitate over there. Yellow precipitate over there. So that is the phosphate, presence of phosphate. So this is a very beautiful test you can do. You can perform in your home also. Just three reagents: nitric acid, ammonium molybdate, and tartric acid. Just three reagents. It will cost you a little bit, but you can perform. And the fourth one is iodine, and this is iodine. Iodine you will get also from the chemist shop in the form of iodine powder. It is in form of crystals, iodine crystals. That also you will get in the chemist shop. All the reagents you will get in the chemist shops. You will get a test tube also there. You can perform your own tests. So all I will give you in the description box, and you can perform it. But in the case of Bunsen burner, you can use your gas burner. If you don't have a Bunsen burner, don't go for Bunsen burner. You can use your gas burner. You can use your normal kitchen gas burner. Just light the burner, put it in a sim, and you hit the test tube. So you can get it over there. So thank you very much from now, and we are going to, in the second part of the video, we are going to show you the microbiological tests. So thank you. Hello friends, we are back with other part of our rice washings, that is the microbiological aspect now. So here is our rice washings. So we will see anything microbiological infection is there or not in these rice washings. So as you can see, it is full of profuse starch. We have to check whether there is a microbiological infection or not, or rather some microbiological objects are present or not, some microbes are present or not. That we will see. So being presence of pesticide, it is obvious that there will be no microbiological aspects, but still we will see any microbiological aspect of that is there or not, because this is full of starch. You can see it is totally milky white, as you have seen in my previous video, that it is milky white. So we are going to check the microbiological aspect. So before that, what we are going to do is that we will be before putting this into the culture media, we will be eliminating the starch. We have to eliminate the starch, because this profuse starch, you cannot see anything. Everything will be blurred. Under microscope, everything will be blurred. So we have to remove the starch by, in these two test tubes, you can see in this camera, in the second camera, yes, you can, in the second camera, you can see in these two test tubes, we will be liquidating 2 ml of the starch of these rice washings, and we will be putting them into the centrifuge. So to remove this artificial milk, as I have named it, is artificial milk, that is starch. So we have to remove this starch, excess starch, profusely excess starch. We have to remove this, and then we can see something, whether it is there or not. We have to put them in the culture media, and then we will see what is there inside the rice washings. So let us go to the centrifuge, put this into the centrifuge, and see. After that we will come back and we will see whether put it into the culture media, and then we will see what is there. So friends, we are back after the centrifugation, and as you can see, our two centrifuges are ready, and you can see in the camera the two centrifuges are ready. Now we have to remove this, we have to take out this water washing, the actual water, with the help of this pipette. We will be taking, after that, before that, we will be putting the culture media. So here we are going to use another culture media, that is Gluconobacter agar. Now this Gluconobacter agar is used for those specimens or those microbes which are associated with starch. So this agar actually makes this Gluconobacter, this microbes which are very familiar with the starch environment. So we are going to give the starch environment. Actually what we are doing, we are removing the starch and again you are putting the starch in the form of glucose, not in the form of starch, because starch is a little bit different than glucose. We are giving glucose, not the starch. Starch is different than glucose. So we are going to give glucose, not the starch. We are removing the glucose. As removing the starch, we have removed the starch and we are putting the glucose. So glucose is much more familiar than starch, much more easily digestible or much more familiar to the bacteria. So 10 ml is enough. So now we are going to inoculate these two things, as you can see, with the help of a pipette. We will just inoculate with the help of 1.8 ml pipette. We will just inoculate, taking this, and first inoculation done, and from the second tube, just opening it, and the second inoculation is done. So this we will leave for 10 days and let us see what is inside. So let us see what is inside. So you can see, and then we have to level it, because without leveling you cannot do anything. So here we are going to level it as rice washings, rice wash, and this is Gluconobacter agar, and this today is 8, 7 and 22. So this is done. This should be done, otherwise you will be in trouble that what is what after before analysis, what is the sample, and you will be in trouble. So this is done, and now we are going to put this into the incubator and wait for 5 to 10 days to see whether anything has occurred or not. So bye from now. Friends, we are back with a video, and we are with that rice washing solutions, and we are testing the rice washing solutions. As you have seen, tested the rice washing solutions, and as you have seen that it is consisting of starch, quite a considerable amount of starch, and quite a considerable amount of pesticide, ammonium phosphate, a cheap pesticide, ammonium phosphate. And in spite of that, we have removed those things and we have tested in the culture media. We have kept that in the culture media, as you have seen the previous part of the video, that we have changed the culture media, put it kept in the culture media, and it is a Gluconobacter agar, and that after 8 days we will be examining that presence of any kind of presence of microbes or not, microbes are there or not, and that we should then after we will decide the further experimentation or further any examination or necessary or not, or anything is there or not. Though there is a pesticide, there is a very less chance of presence of microbes, but ammonium phosphate is not a reliable pesticide, as knows that it is a very cheap pesticide and is a very not a reliable pesticide. Therefore we are going to see whether is there any presence of microbes or not, that we will be discussing, deciding after the microscopic examinations, and we will be seeing that just in the next part of the video. So we are going to begin the experiment, and please be experiment. So please be with us with the later part of the video. Thank you very much. Hello friends, so we are back with the experiment. As you can see, the rice washings in this camera, that it has become very cloudy. So we expect some microbes are there, but along with this there were pesticides were there. So maybe there is no microbes will be there. So maybe not. That is the question. So let us see whether it is there or not. Well, it has become cloudy. So let us see if there is something or not. So according to that we will decide the further experiments. So this is we will take around 1.8 ml to 2 ml, and we will see whether there is anything present or not. So this is our rice washings in the petri dish, as you can see in the camera. So we are going to do the experiment. So let us see what is there in the micro. As you can see, this is Marruzzium mold. It is a very critical fungus in front of you, and this is have been found in these rice washings, and this is a confirmed Marruzzium mold, and this is a mold fungus. In spite of the pesticides, this fungus has not got reduced. So this is Marruzzium mold. So this is a very critical fungus, and as you can see in the front of the screen is the mold patch. It is little bit hazy because of the culture media. So the light is decreased now. You can see the Marruzzium mold, and now the light is decreased and you can see the Marruzzium mold. This is 200x magnification, and you can see the Marruzzium nodes floating around like the flagella of the mold. So this is a very big mold, as you can see in the center of the screen. So this is Marruzzium mold. So in spite of the presence of pesticides, it didn't work. So this is a Marruzzium mold. Generally, ammonium phosphate is not a very good pesticide. It is just a pesticide looking thing, but it is not a pesticide. Anyway, the Marruzzium mold is a very dangerous mold, and we have to be careful about this, and we will be further investigating about this mold. And after 3 or 4 days, we will be coming back with another part of the video regarding this Marruzzium mold. So as you can see the structure of the mold, it is almost like a black fungus, and this is all about Marruzzium mold. So we are back after 24 hours actually because of this Marruzzium fungus, Marruzzium mold, and we have decided one thing, that we will be putting this Marruzzium mold, we will be changing the culture media actually. This Gluconobacter agar is very cloudy agar, so it actually supports all types of microorganisms, and it is very sensitive agar, but it is very cloudy medium. Because of presence of glucose, it is cloudy, very cloudy, and the presence of starch in the Marruzzium mold has also made it more cloudy. So to make it more visible and make it more presentable to view, we have decided to change the culture media from Gluconobacter agar to Clostridium medium. This Clostridium medium will help us to see in all conditions all the parameters of the growth parameters of this Marruzzium mold, and therefore we will be able to see that how the mold is and how it looks like and how it is configured and what is it. So therefore we are going to change the culture media in this session, and after that, after 5 days or 10 days, we will next make a second observation at a microscope, and then we will decide for fluorescence and etc. etc. and etc. So let us go for that change of culture media session, and just we will centrifuge and we will change the culture media. So that procedure you will watch and you will see what it is and how it looks like. So let's go on to the next session. Hello friends, so we have started our experiments, and as you can see in these two inoculates, we have the inoculates are ready. Just we have eliminated the centrifugal part, so the inoculates are ready. So we are just beginning the change of culture media. So we will just first we will take one pipette and we will just remove the culture media, excess culture media, and we will put this into the culture flask. So this is the elimination. This we are just removing the excess culture media, as you can see in the camera. Just we are removing this is your fungus. So you can see in this camera well. So here is the fungus. So the camera is focusing, as you can see. So this is the fungus. So here also in this camera you can see clearly the light is and here is the fungus. So this is white fungus. Marruzzium is white. Marruzzium mold is white. So because it is a starch accumulating fungus, so it is white. And also because of this Gluconobacter agar, the same thing, we are just eliminating. As it is the same thing, so we need not to change the pipette tip, just eliminate the fungus. So here it is done. So this is done. So now we will be putting little bit culture media into these inoculants. Just 1 ml of this culture media in this inoculants and mix well. We can vortex also, but that will take time and not necessary. So this is ready, and we will change the pivot tip because that is fungus affected, so you have to change the tip. This you should take care, be careful when you are doing the microbiological experiments. This you should not hurry. So how to do this, I'll show in the camera, and just refluxing it, and it is ready. So these two inoculants are ready. So now we are going to take around 10 ml of the Clostridium fungus, Clostridium medium, and a sterile pipette. Take the sterile pipette, and this is a sterile pipette, and out of this steady pet pump we will just take around 10 ml. So this is 5 ml coming up, and this is 5 ml going, and another 5 ml we will use. So this is done. So we will keep the pipette here so ever and close the culture media. Then we will take another pipette, another 1 ml pipette, or you can take a 2 ml pipette, whatever you like, just a big pipette, and pump it out. So inoculant gone. So one tube is gone, so another tube, and this is just pump it out, and inoculant are in. So this is done. So friends, our culture media is ready. So the flask is ready. Now we need to cork it, and the same way the tissue paper should be folded half, and some cotton is needed. Some cotton is needed, and just roll it. You can see in the camera, I just roll it and just fold it, just flush it with alcohol and put it in the flask. So this is ready. You can see in the camera, it is ready. So it is ready for inoculation. And now we need to, so this is Marruzzium inoculate. So this Clostridium medium, and today is 15th or 16th 7/22. So this will be kept in the incubator, and for incubation, and we will be coming after 10 days, because this Clostridium medium is a slow medium, so it takes 10 days to generate the fungus. But don't know what Marruzzium will do. So if it brings us, it wants to bring us faster, then it will, earlier, then it will go fast. If it goes faster, then we will come earlier. Otherwise we will come after 10 days as you do. So let us goodbye from now. Hello friends, so we are back after 3 days with this Marruzzium fungus, Marruzzium mold, and we will be surprised that well, I am also surprised that this Marruzzium mold is showing some different method, different ways, different properties actually. So what we expected, that Clostridium medium is a very slow medium and it will progress very slowly, but it has turned opposite. So it has made a very fast progress, and we will be seeing some filmy adhesion type fungus here. It has formed the filmy films on the surface of the Clostridium medium, which is very fine thin films, which is not visible in the naked eye. It is almost invisible in the naked eye. We will be seeing in the microscope just the left hand side of myself, and we will be discussing this in the later on in the videos, and we will be doing some more experiments. This will be our second investigation, and we will be watching the growth of this fungus, this Marruzzium mold under Clostridium medium. So definitely we will do something else and we will proceed it. So let us begin our second investigation, and please be with us on the later part of this video. Thank you very much. Hello friends, so we will be beginning the experiment. As you can see, this is our Marruzzium fungus. If you can see in the camera, so filmy as these films are, the filmy fungus, that the fungus films are visible inside the flask. Perhaps, I don't know, but it is there. So let us see. We will take some inoculants, or rather take some samples with the pipette, our pipette, and we will be seeing it under the M400 microscope. So these are the films, and some of the films we have taken, and it's a very fine film which is almost invisible in the naked eye. So this we will check under the M400 microscope. So let us begin the visualization. So this is our fungus. So as you can see, the Marruzzium mold in front of you, and this is 200x magnification, and you can see the other parts of the slide, other parts of the specimen. So Marruzzium is forming. This is the flimsies formations, and you can see these are the small Marruzzium. So this is the second investigation, and therefore the films are not yet formed very properly. We will see a very big growth in the third investigation as presumed. So this is the Marruzzium mosaic. This is a Marruzzium mold actually. It's a mold oocyte. This is a small oocyte, the small Marruzzium. So this is the Marruzzium mold, Marruzzium mosaic. So very tiny, almost 10 microns in diameter. So 10 micrometer in diameter. So these are the oocytes, and you can see the Marruzzium mold. So this is the other parts of the specimen, and we are trying to see the any large mold, but still not yet visible, but we are searching for it. So this is another Marruzzium mold in the top of the screen. So these are the small Marruzzium films, the sections of the small Marruzzium films. So this is a Marruzzium mold. I can see in the form, this is a very big Marruzzium mold. We have to decrease the magnification. So this is 200x magnification. You can see the Marruzzium mold. This is the matured Marruzzium mold. So we have to decrease the magnification to make you see the whole thing. We have to decrease the magnification. So we are decreasing the magnification to 100x, and you can see the complete structure of the Marruzzium mold. This is the mold formation. It's a dark mold formation. So almost similar to black mold. As you can see, this is the complete structure of the Marruzzium mold. So it is in front of you. So let us see what more we can see. And this is Marruzzium mold almost. So this is a very good vision of the Marruzzium mold in front of you. It is 100x magnification. So this is Marruzzium mold. In front of you, this is Marruzzium mold, and this is 100x magnification. So we are looking for others. Any more molds are not there, but this is almost the end of the specimen. Some flimsy adhesions are there. There just Marruzzium molds are hanging. Some mold formations are hanging actually. So the microscope is. We are trying to focus in a different layer, but it is not possible because as the Clostridium medium is very thick medium, so it is not possible. So we are ending up the vision over here. Hello friends, so we are returned after 5 days and with the same Marruzzium fungus, and this time we are going to investigate third time to investigate the film, the formation of the film third time. And with the help of this time we will be using a buffer, a special buffer called the citrate buffer, and now this is an acid buffer. So we are going to see the cell deformation and the cell casting and the cell configuration of the citrate buffer, if it is possible, that we will study. So and also we will see the formation of the buffer, formation of the fungus, and thereafter after 5 days more we will be doing the fluorescence study. So let us begin the experiment. We will be doing the citrate buffer. Regarding the citrate buffer, I must say that it is an acid buffer, and this buffer also is composed of two different chemicals. One is citric acid, another is sodium citrate. It is a combination of the two chemicals. One is citric acid, another is sodium citrate, and these two are in a ratio of 1 molar, 0.1 molar. And they are configured in the ratio of almost 50-50 to get a pH of 4.5 like that, and therefore we will be using that in the acidic base with the acidic fungus, the Marruzzium fungus, to adulyze the protein or the starch formation. So it also adulyzes the protein, and it also adulyzes the starch. So we have to adulyze the starch from the fungus, and we will just isolate the fungus and we will see the configuration and the other systems of this fungus. So let us begin the experiment. Hello friends, so we are back with the experiment, and as you can see in the camera, and this is my second camera, that these two are the buffers, the main stock solution of the buffers. One is citric acid buffer and it is labeled as A, and this is sodium citrate buffer that is labeled as B. So you have to mix these two, and the sodium citric acid should be mixed in 25 ml with the 24.5 ml, and the citrate acid buffer will be used for 24.5 ml. So just on 1 ml difference, nothing else. So it is almost 50-50. So in this clear tube we will be taking 24.5 ml of this citric acid, and we will be using one pipette, a sterile pipette, and we will be using this citric acid. So here is our pipette. We will switch on it, and you can see just when our buffer will be ready, we will start our main experiment. So let us this is 10 ml, This is 15 ml. This is 20 ml. So this is 20 ml. So another 4 ml will do. So this is around 4 ml. And little bit. And that's it. So this is complete. Now this is complete. So this needs to be, so one buffer is complete. Now we have to remove the tube because this is something, and now another tube should be taken, and another tube should be taken, and this we will add the sodium citrate. Now this is sodium citrate, just, and this is same as 25 ml. So this is 5 ml, and this is another 5 ml. This is another 5 ml. So this is another 5 ml. So this is another 5 ml, and this is another 5 ml. So this much. So this is done. Our buffer is ready. Our acid buffer is ready. Now this is our working solution. Mixing these two is our working solution. This is little bit different from our sodium glycate buffer, because sodium glycate buffer was an amino acid buffer, alkaline amino acid buffer. So, or rather an amino acid salt buffer. So that was neutral, but now this is acidic, just to release the protein. Citrate buffer used to glycinate buffer actually used to adulize to separate the culture media. The total media was lightened or diluted by the glycine, because glycine was such a buffer, such an amino acid. It is an amino acid, so it will not do any harm to the fungal media. So the fungal media won't be disturbed. But saline, normal saline or something else, glucose and all that, used to can harm the fungal media. So citrate buffer also does not harm this culture media, but it can lacerate the culture media. So this will be little bit, this buffer should be carefully used. So I am removing the extra tubes here, the extra bottles here. So these are not necessary now. So this you can keep in the racks. Only thing is that you will be going to use this. So here now we are going to use this citrate buffer. So here now we are going to use the citrate buffer. So now again now I'm putting the camera a little bit down so that you can see properly. Yes, you can see now you can see. So here we are going to use this citrate buffer, and first we are going to take around 2 ml of this fungal media. Okay, like before, this we are going to take the fungal media, and here is our fungal media, and we are going to use around 0.5 ml of this buffer, just 0.5 ml of this buffer. We have to add just a tube to 0.5 ml. This auto pipette you have to adjust, and This is 5 ml. You can see in the camera. So you can see this is dark actually. You can see in this camera. I think you'll have to see in this camera. So it is 5 ml. So you can see this is 5 ml. So 500 ml. That is 500. So that you can see 050. Sorry, 050. You can see the 050 button. So that is 50 into 10. That is 500 ml. So now we are going to take the tip and we will be using this buffer. So here is our tip and this inside, and this is our buffer. So just you can see in the camera and just adding and the buffer, and so it has been naturate and it has been decolorized and also delacerated. Now you can see under tissue implanted microscope any of the fungal media is present or not. So that we are going to see under tissue implanted microscope. So friends, this is our Marruzzium fungus, and you can see the starting of the Marruzzium fungus. You can see the tiny Marruzzium stealth also, and the Marruzzium fungus is there and is keeping just, you can see the formation of the cell. We are just moving the petri dish from this side to that side to see more Marruzzium formations, and this is also a, this is nothing as such, just formation, and this here you can see the Marruzzium mold. Now it is looking transparent because of the presence of citrate vapor. This has happened due to the presence of citrate vapor, so that we can see the outline. Now here in the corner of the screen you can see the Marruzzium maturing Marruzzium mold. So in the center of the screen you can see this is the maturing Marruzzium mold. So this is a very beautiful fungus and very dangerous. So in our third attempt we can see this is circular in origin, and the contrast is increasing. Now you are increasing the phase contrast, and you can see this is the Marruzzium mold. So you can see the beautiful structure of the Marruzzium mold. So this is the structure, and you can see some other parts if you want to see some. This is the these are the citrate activated Marruzzium molds. These are the citrate activated Marruzzium formation. The Marruzzium is forming actually. The Marruzzium is forming, you can see. So this is the same Marruzzium mold, and we are going to try to see the other part, and so these are the Marruzzium molds, the flimsy molds. The mold is very flimsy, so it is not very much proper in the microscope, and this is almost all about. These are the Marruzzium molds, formation of the Marruzzium molds, the same formation of the Marruzzium molds. Because of the citrate vapor, as I have told you, this is the Marruzzium spores actually, which will convert into molds. This is a sporadic fungus, spore fungus. So these are the microspores. So this is almost all about Marruzzium mold. So this is Marruzzium mold in front of you. This is the FLR view. You can see the Marruzzium cells, and these are the Marruzzium stylets. These are the small stylets of the Marruzzium. These carries the mycotoxin. The microscope is focused, and you see in the 400x magnification that this is Marruzzium mold. As you can see the developed Marruzzium mold in front of you in the center of the screen. The microscope is a little bit focused, and you can see in the center of the screen this is the very beautiful Marruzzium mold. The mycotoxin is in the center. This is the matured Marruzzium cells. These are the matured Marruzzium cells. Now the stylets are found. These are the Marruzzium stylets. These are the Marruzzium stylets. These consists of this contaminates the other specimen with the other things with the mycotoxin. this goes out from the Marruzzium cell. As you can see, the cells are ruptured. These are the ruptured Marruzzium cells, and the stylets are everywhere, and some of the cells are dead also. So this is the Marruzzium mold fungus in front of you. So this you can see, this is the Marruzzium mold, and these are the other parts of the slide. You can see these are the other parts of the slide, and this is Marruzzium mold. It's a very beautiful fungus and very dangerous also. These are the dead cells. Actually, these are dead cells. So generally, Marruzzium is not a very strong fungus, but it is a very dangerous fungus. If it acquires anything, it destroys. So we should be very careful about this Marruzzium fungus, and this is starch-oriented fungus, and the mycotoxin is dicothecin, which is having a sharp wavelength at 214 nanometer. So we will find out the mycotoxin, we will identify the mycotoxin. So what mycotoxin it is from the wavelength scan after just to follow the video. So this part is full of mycotoxin. You can see it is illuminated. Light is coming out. The fluorescence light is coming out. So this is a Marruzzium mold fungus. You can see the mycotoxin inside. Very carefully you can see the mycotoxin inside. In the right hand side, almost in the right hand side part of the arrow, it is coming in the center of the screen. So you can see the Marruzzium mold. So this is the mycotoxin. So as such, we are finishing up with the slide. So this is as much. As you can see from the UV spectrum, the three mycotoxins are present. At 370 it is lysergic acid, at 210 it is Roridrin, and at 214 it is Fumonicin. So three mycotoxins, dangerous mycotoxins are present, and one of them is lysergic acid. It is a very dangerous mycotoxin, and the last one at 665 it is solvent. So this is all about Marruzzium fungus mycotoxin.